Well, Math 2 students, we are here at the end of our Unit 3 and ready to take the test on it. So let's get to it. Now, a little word about how to use this video. Remember, the least useful way for you to use this video is to watch it and copy down what I do. This is a guide to check your own work. So I encourage you to use that pause button liberally. So, please remember to use pause when to try it yourself. Okay? Even if that means in the middle of a problem, you say, oh, I don't know what to do. Oh, he explains what to do. Pause, try it yourself, then check. It's the best way to use this video. So, first we start off with graphing these functions, identifying the vertex and the zeros. A couple different strategies we could use. So the first thing when we want to graph is we want to get the vertex. If we don't know where our vertex is, we kind of don't know how to define a parabola. This is vertex form. So I'll have that for you, vertex form, up on the board or available to you, so you don't have to memorize that, but you need at least be able to recognize this is vertex form, and this tells me my vertex is, when we have x minus h plus k, that means that h must equal -4 and k must equal 6. Remember that if we have a minus h here and it's a positive number, what we're saying is the opposite sign. So -4 comma 6, -4 comma 6, so we'll go up there. So there's my vertex. Now I have an a of -1/2. Okay. So think a couple ways you could do this. You could create a regular table. You could say, okay, if x is -4, what is y? And so what is my pair? So -4, we know we're going to get 6. I'll show you. -1/2 times -4 plus 4 squared plus 6 equals 0 plus 6, right? This equals 0, 6. And then on either side, -3, -2. So -1/2 times -3 plus 4 squared plus 6 equals, this is going to be -1/2 plus 6, which is -5.5. So -3 comma -5.5. -2, you're going to be at -1/2 times -2 plus 4 squared, so that's plus 6, which is going to be -1/2 times 4 plus 6, so that's going to be 6 minus 2, or 4. Excuse me. Yeah. I think I made a mistake here. This is not -5/2, it's 5/2. 4, and so this would be -2 comma 4. So this is how to do a whole table, and you're welcome to grab some scratch paper. I prefer to just use my vertex as a starting point and then think of what's my standard parabola. So usually I go over 1 and up 1 and over 2 and up 4 and over 3 and up 9. Usual. But times -1/2, this is going to be 1 times -1/2 is -2. Excuse me, this one, right? Normally I go up 1. This time I'm going to go down 1/2. Normally I go up 4 times negative 1/2 is going to be down 2. Normally go up 9 times negative 1/2, your calculator can help you here, is negative 4.5 or negative 4.5. So this kind of table is not a table of points like this. Okay? This is different. This is just a table of how do you move from the vertex. So this is from the vertex. You've got an over and a up or down. So that means from the vertex I go over 1 and down 1/2, over 2, down 2, over 3, down 1, 2, 3, 4.5. Okay. I noticed in class I'm still seeing a number of parabolas that don't really look like parabolas. They look straight. So remember that a parabola is not this. That's not a parabola. A parabola is not this, right? Not parabolas. Parabola has a continuously widening. So this is a parabola. If you're not sure, make some more points, okay? All right, my zeros. So zeros on this one, I would just be looking for an approximate if it's not at an obvious point. So we can say this is negative 7.5 and this is negative 0.5. That's close enough. Moving on to number 2. Here a 0 is actually going to be something very much defined. We're saying what makes y 0? Right? Here's y equals 0 is going to be anywhere along this. So what's going to make y 0? Well, if x equals negative 1, then we're going to have a negative 1 plus a 1 that's going to be a 0. So we'd have 3 times 0 times who knows what, or who cares, because anytime we have a times 0, we're going to get a 0. So 0 is going to be negative 1. Or if x equals negative 3. If x equals negative 3, this becomes a 0. And then if this is 0, it's 0 times something times 3. Doesn't matter what any of these things are. If this is a 0, then we're going to get a 0 after multiplying. So negative 3. Another way of putting this is to say, when does x plus 1 equal 0? And, or, when does x plus 3 equal 0? Those are both. So that means at x equals negative 1 and x equals negative 3, I have my zeros. Now, the vertex, right, just like we had here zeros, just we had zeros here, and our vertex is halfway in between those, right? That's true of any parabola. They're symmetrical. So that means my vertex is somewhere along this axis of symmetry, this line of symmetry. We can find this very precisely by taking an average of my zeros. So if I say negative 1 plus negative 3 over 2, that's negative 4 over 2, which equals negative 2. Right? So the midpoint is negative 2. That's important because I need to know where my vertex is. And to find the vertex, I have to know both the x-coordinate and the y-coordinate. So my x-coordinate is negative 2. That's what I found. Now I need to know how far up or down it is. So I can use this to plug it into the equation. So y equals 3 times, now I have an x value, negative 2 plus 1, times negative 2 plus 3. 3 times negative 1 times 1. Remember my order of operations? Means we take care of the inside of the parentheses first. So I've got 3 times -1 times 1 is -3. So that means my vertex is here. Now, some of you are going to say, you know what, that seems like a long process. Can I just look at what A is and say 3? Yes. If you can look at it and say A is 3, therefore I would go over 1 and up 3, so I'm going to work backwards from these points and realize that that's my vertex, that's fine. Okay? So this is what we needed to define a parabola. Remember that a parabola keeps increasing in terms of it keeps spreading wider. So don't go straight vertical at this point. Over 2 normally would be up 4. We'd have to go up 12. So that does take us from -3 actually up to -9. So it's not on our graph. So that's number 2. Number 3, we've got a standard form equation. So we still need to find the vertex. But now we have to use our -b over 2a formula. So -b over 2a, that's a equals 1/2. B equals -4. So -b over 2a equals -4 over 2 times 1/2. Well, 2/2 is 1, so this is going to be +4 over 1, which is 4. Okay? Now notice this is my equation x equals. So what do we do with this? We say that's my x value. Okay. Once I have my x value, how do I get the other part of my vertex? The same way I did here, which is to find the y value by plugging it in. So this is 1/2 times 4 squared minus 4 times 4 plus 2. So this is 1/2 of 16 minus 4 times 4 is 16 plus 2. This is 8 minus 16 plus 2. We go 10. I'm getting to 8 plus 2 minus 16. That's how I like to figure these things in my head, is combine all the positive numbers. But however you figure it, even on a calculator, is going to equal -6. So this is my y. Y equals. So I've got -6. And then I've got, so 4, -6. And now I've got a equals 1/2. So that means up, normal, and times a. Normally it's up 1, or excuse me, over normal up. I know what I meant in my head, but I didn't say it. Normal is over 1, so is an up 1. So times 1/2 is going to be up 1/2. Normally we go over 2 and up 4. So this is going to be half of that, or 2. Normally we go over 3 and up 9. So this is going to be half of that, and 4.5. So one more time, these are not points, these are distances from the vertex. Over 1, up 1/2. Over 2, up 2. Over 3, up 1, 2, 3, 4.5. Over 4, up 2, 4, 6, 8. I didn't show you the calculation on that, but that's what it is. So and even this parabola, I kind of pointed the bottom, and it's not like that. All right, there's my parabola. Write this function in standard form. Standard form is like this, right? We have no parentheses, no parentheses. Everything's simplified. So what we need to do is take this part right here and box method that. Just do that and then put everything back where it's supposed to go. So here's x minus 9, x minus 9. Some of you may notice a pattern, and I hope you do, that anytime we have a binomial here squared, we ended up with the first term squared, 2 of the first and second term multiplied, or minus 18x, right? So this is like 9 times x, negative 9 times x times 2 there. And then negative 9 times negative 9 is plus 81. Still seeing a few of you want to look at a negative 9 and negative 9 and say, yeah, those cancel out, but they're both negative. So they become negative 18. They don't cancel each other out. All right, so this goes inside that. So this is negative 2. Now we've multiplied that through instead of having an exponent. We've said, let's actually do the multiplication. 81 plus 14. Okay. Notice all I did was take this and I said, let's do the box method and then put it back in parentheses because the negative 2 still has to multiply this thing. So now I'm going to say y equals negative 2x squared. Negative 2 times negative 18 is positive 36x. Negative 2 times 81 is positive 162. Excuse me, not positive. Negative 162. So last thing is combine like terms. Minus 162 plus 14. That's going to be negative 148. Yep. I'm going to double check that because it's a test and I really don't want to just get a point off for a silly arithmetic error. 162 minus that plus 14. Negative 148. Yes, good. My mental math is working. All right. So just a little bit pause here for a second and talk about a test prep. Remember, preparing yourself by studying this, by practicing yourself is good. Also thinking about how taking it and going like, yeah, on the test, this is what I'm going to do. I'm going to do this process because I've learned this. That positive self-talk, as much as you can muster, is really, really important so that you have the frame of mind that allows you to succeed in the test. Brain scientists know this. It's not about pretending. It's about really focusing on what can be positive because that helps you think more clearly. Okay? It's not going to help you think more clearly to beat yourself up. Similar process here. Again, we're going to box method this so that we can multiply this through. Then we'll do the multiplication. So this is 8x minus 8 and x plus 10. X squared minus 8x plus 10x minus 80. So I've got 3 halves times this becomes a plus 2x. So this is x squared plus 2x minus 80. And then we multiply the 3 halves through. 3 halves x squared plus 3 halves times 2x minus 3 halves times 80. You don't like fractions? Do 1.5. Okay. So this is 3 halves x squared. See, can you see that? Plus 3x, 1.5 times 80, minus 120. There is my answer for that. All right, turning over. Number 6. Given the table, identify the vertex, and using that and one other point, find the equation in the vertex form. So, if we were to notice what was happening with our y values, right? Our y values, this is our y-axis, and it goes from negative 10 to positive 10 to 22 to 26 and then it goes back down again. So as I'm going from x is -2, -1, 0, 1, 2, 3, 4, I can see that it's going 0, 22, something like that. This is a real quick sketch of how this table shows y getting bigger and then getting smaller, just like if you threw a ball in the air. So our vertex is at the very top. So which value is that? Well, if we look at our y values, we can see that it goes up, 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 and then it goes back down. So this must be our vertex. This is 126. Another point. It can be anything. How about we do 0, 22? So find the equation in vertex form. Vertex form, y equals a times x minus h squared plus k. So I've got my h and k here at the vertex. That means that y equals, I'm going to do it here, y equals, I don't know what a is yet, x minus 1 squared plus 26. Now we need to use another point to find a. So let's put this point in here. Y 22 equals, that's my y, equals a, the thing I don't yet know, times 0 minus 1 squared plus 26. If you try and use the vertex again, it won't work. You'll get a 0 equals 0. So that's not going to help you find a. So 22 equals a times -1 squared plus 26. I encourage you not to rush through this and try and do a bunch in your head, because it's easy to miss the negative or get something wrong there. -1 times -1 is 1, so this is a times 1 plus 26 equals 22. Or a plus 26 equals 22. So subtract 26 from both sides, and I get a equals -4. So my equation is y equals, a is now -4, we know that, x minus 1 squared plus 26. If you're able to just look at the change here and go, oh look, from here it's 2, or from here it's 4, right? Normal, it's 1, 1, this is 1, 4, and then it's 2 and, excuse me, normally it's 1, 4, and then 2, and this is, normally it's 2, 4, and now it's 2, 16. If you can do that and figure out a regularly, accurately, precisely, more power to you. That's awesome. But you also have to notice that it's going down. So I think the algebra method is probably going to be more reliable. All right, given the following graph, write the equation in intercept form. Just the graph. Well, we can do this a couple ways, except we want to do intercept form. So normally writing the equation, we would say, oh, I could write it in vertex form. But we need to write this in intercept form. So look, I've got my intercepts here, 0, 6,